Perfect. Alrighty. Well, it's really great to be here. I know it's later in the evening for all of you, so thank you so much for taking the time to be here as well. I hope you will find it a meaningful presentation, as well as some live coding, so you will have to be awake for some of it as well. So if I'll just go ahead and share my screen. Okay, cool. Perfect. You should be able to see that now. So if you know Python, then you know blockchain. My name is Sarah Jane Kenny. I'm a junior developer community advocate at the Algorand Foundation, and I'll be running you through some different topics. So we'll be going a little bit through what is blockchain, what is Algorand, then a little bit inside of the tech as well, because it's always important to know what you're building on top of, as well as what we can provide for developers, builders like yourself. And before we go straight into the live coding, I will take you just through very quickly 4 projects that are building on Algorand, that are real world, that you may be able to take inspiration from. After that, I'll just show you a nice showcase of the ecosystem and what we're doing and how we can support you and continue in your journey. So let's get started straight away. What is a blockchain? And for anyone who was here in our first part, I think it was maybe a month ago, and you've already sort of seen through the intro section, feel free to make a cup of tea or you can relax on this part. But for those of you who are new to blockchain, if this is your first time hearing about blockchain, it's always important. So blockchain or distributed ledger technology has 3 main factors. So it's decentralized, a network of nodes around the world working together to reach a consensus. And nodes are basically just the computers. Has to be trustless. The information or data on the network is accessible and verifiable. And it's immutable. So information cannot be changed or interfered with. The history can never change. Simply to think about blockchain is a database that can only append data. So how is this all happening? So it works by a chain of blocks, hence blockchain. So with transactions, they state a change in the ledger. And all of these transactions are inside of blocks, which hold an atomic collection of the transactions. And each of these blocks with the transactions inside of it is chained together by a cryptographic hash. The transaction is the important part. So how do transactions work? Firstly, with the formation, transactions are standardized data structures. They describe desired change to the ledger, and each transaction has one sender. With that, then you also need a signer of the transaction. So accounts in the ledger identify via an address. Each address corresponds to a public key and a private or secret key, and the secret key is used to sign the transactions. I did see a chat notification, so I'll just quickly have a look. Can you guys see my screen? Can we get some thumbs up in the chat if you can see the screen? For those of you who might have joined late, you might have missed the agenda, but basically I'll reiterate really quickly. We'll be going through a little bit about blockchain just as a base, then about Algorand, doing some live coding together, and then how we can continue to support you guys afterward. But also, if we can keep all the questions right till the end, so we can keep it smooth with the time as well, because I know it is a little late for you. But if we continue now, the other part of transactions, the end part, is to submit. So you submit transactions to one or more nodes. Each node in the network validates that transaction, and then the transaction can be added to a block. And this is in the general scheme of things. So reaching a consensus. Consensus refers to the way blocks are selected and written to the blockchain. So a trustless model means anyone can participate in the securing of the network. So what is a consensus mechanism? The most important and fundamental task in a blockchain is the secure, reliable, and fast creation of the next block in the chain. The tool to create and validate the next block in a blockchain is called the consensus mechanism. So early blockchains used a consensus mechanism called proof of work, like Bitcoin, that solved compute and intensive hashing challenges. While this was useful at the time to prove out the concept of blockchain, it has been shown to be very slow, expensive, and energy inefficient way to write the next block in the chain. And there are others like proof of stake, where you hold a stake in the network. Algorand takes the next step forward and uses an innovative consensus mechanism called pure proof of stake to write the next block in the Algorand chain, which I'll talk a little bit about later as well. So what is Algorand? In one sentence, Algorand is an enterprise-grade programmable layer 1 blockchain with instant finality and low fees, enabling consistently high transactions per second and requiring minimal energy use. So how did this all come about? Well, if we start back at the roots and the origins, the founder Silvio Micali is an Italian computer scientist and MIT professor. He's also known as one of the modern forefathers of cryptography, thanks to his work such as co-inventing probabilistic encryption, zero-knowledge proofs, verifiably random functions, and of course Algorand, which was founded in 2017, but the first Genesis block, so basically the first block made on mainnet, was in June of 2019. For those of you who may be interested in cryptography or blockchain security, in a more short sentence, probabilistic encryption means enhancing encryption security by producing different cipher texts for the same plain text. Zero-knowledge proofs allowed verification of information without actually revealing the information. Lastly, verifiably random functions generate publicly verifiable random outputs, essential for secure and fair randomness in cryptographic applications. The number one question people ask, and it should be asked, is what makes Algorand different from other blockchains like Ethereum? So we are ready for global adoption. Algorand has an elegant consensus mechanism that enables true scalability that can handle over 10,000 transactions per second. Our blockchain is trustlessly truthful. So with instant finality and a block time under 3 seconds, you can be sure your completed transactions stand as an unalterable or unchangeable truth. Instant finality basically means once the transactions are processed, they are added to the network instantly. There's no waiting time. We're also designed to endure. We have an ongoing drive towards true decentralization, which will make Algorand one of the most reliable and resilient blockchain platforms in the world. And lastly, we're leading on post-quantum. So on Algorand, we have a quantum-safe state proof that utilizes Falcon signatures. Once again, for any of the cryptography heads, it is a lattice-based signature. So every 256 blocks, around 12 minutes, state proofs ensure the entire history of the ledger, so all of the transactions, is secure against potential threats. This is quite important because we shouldn't fear new technology like quantum computers, supercomputers. At the foundation, we're preparing now for quantum computers instead of waiting for the problem to come and fixing it then. So let's actually take a look at the numbers. So as mentioned, Algorand can theoretically do 10,000 transactions per second. We have a second block time less than 3 seconds. And we have a 0.001 algo fee per transaction. And this is equal to a tenth of a US penny. We also have 0 seconds to reach finality, which is quite unique. Instant finality just means once the block time is processed, the entire process is finished. It's instantly added. It's quite important. It's definitely a need for consumer adoption and for payments as well, if you're thinking about building a payments app. Algorand mathematically is near impossible to fork, and I will explain what that means too, just for anybody who might be completely new to blockchain in a few moments. And we also have 0 downtime since inception, which is great for reliability. So if we take a look at the bottom row, you can see some cool numbers as well. So as of June 2024, it has been recorded Algorand has produced over 40 million blocks, a huge 2 billion transactions, and over 800,000 active monthly users on chain. So how does this all really work? How is this made possible? So if we take a quick look inside the core technology, you can see it's a technology you can trust. As we went through earlier, lightning fast speeds, never wait for confirmation, transactions are final, instantly, and block time is under 3 seconds. There's no transaction manipulation, and this part is really important. It's kind of the whole blockchain ethos. So no forking, no rollbacks, and no nonce management means simpler building, easier maintenance, and lower go-to-market costs. A fork is basically when a blockchain splits into two competing paths. In the end, one of the paths gets deleted, including all of the transactions that were on it. So we have to keep authenticity and rarity where it needs to be. We can't just fork. And I use an example like the Mona Lisa. If there's one Mona Lisa and that's what makes it precious, if there was two of them, it wouldn't be as precious. And then basically a rollback is when a series of confirmed transactions get reversed as if they didn't happen. That's not very decentralized. With quantum security, we are 1/3 of the way to being a pure quantum secure blockchain. Right now, we just have the history, but further research and development underway for quantum secure VRF within the consensus mechanism and transaction signature scheme. We're energy efficient as always. This is a cool fact. Powering the entire network requires around 80 kilowatts, the equivalent of charging a Tesla car. Now onto more of the technical things. Everything, well, it's all been technical, but onto the more dev interesting things. So everything you need in a layer one. So Algorand smart contracts. Algorand makes it easy to tokenize, transfer, and program conditions on any instrument of value. You can create fungible and non-fungible tokens with a single transaction where no smart contract code is required. And we will be doing this later. Or you can program more sophisticated decentralized applications with Algorand smart contracts. Developers can now write smart contracts in native Python or TypeScript and use one of our 4 SDKs like Python, JavaScript, Golang, and Java to connect to on-chain assets or applications. And you may see there's Algorand stateless smart contracts. And these programs enforce logic for transactions on the blockchain without storing any data, ensuring that certain conditions are met before a transaction is approved. Next, we can see Algorand standard assets, and we will be creating one of these later. They're basically just the assets on the Algorand chain. So as you probably already guessed, they inherit all of the pros of the Algorand network, from efficiency, scalability, and security. Next, atomic transfers are really cool. Algorand's atomic transfer feature allows multiple transactions to be grouped together and executed atomically, ensuring that either all transactions succeed or none of them do. And this is key for truly trustless transactions. You don't need a smart contract to perform these types of transactions either. We also have some on-chain randomness. So you guys are developers, you know computers are deterministic programs. So you give a computer program an input, it gives you an output. If you give it the same input again, it will give you the same output again every time. And that is predictable. So having a source of trusted and secure randomness is necessary for decentralized applications that depend on randomized processes, such as lotteries, random NFT drops, games, etc. You can do some cool things with them. And lastly, on the Algorand state proofs not only allow for post-quantum security, but also enables trustless bridging between different networks like Ethereum. I did mention I was going to talk about the Algorand consensus mechanism just briefly, as I've already explained what a consensus mechanism is. So this is how Algorand works. It requires 3 steps to propose, confirm, and write the block to the blockchain. These steps are: number 1, the propose phase. One account is chosen to propose the block. Number 2, the soft vote phase. A committee is chosen to soft vote on the proposal. Number 3, the certify phase. A new committee is chosen to vote on certifying the block. Each block has a new proposer and new committees chosen at random using the power of VRF, and that's the key. This leads to player replaceability, a powerful tool that enhances security. Anybody who has a token can participate. There's no static target to attack. There's not a lot of heavy computation or debilitating energy consumption either, as VRF is known as a quote-unquote simple task. And this entire process takes less than 3 seconds. So a lot of you may be Ethereum developers, maybe you use Solidity. But if we were to compare the Algorand virtual machine and the Ethereum virtual machine, we can see a few things. So while transactions per second measure how many transactions the blockchain can process per second, time to finality, which is the third one in the presentation, time to finality measures the time it takes for a transaction to become irreversible once it is confirmed and added to the blockchain. So as we can see, Ethereum can handle a scale of 56 transactions per second, 12-second block times, and 12 to 16 minutes for finality. So if you compare that to Algorand, there is quite a jump into the modern day blockchain. If we also talk about the programmability, Ethereum has solidity, which means you would need to learn a new language to build on-chain rather than use a traditional language you would learn in high school or college. And you may think, what about Viper on Ethereum? But Viper is not native Python, but a distinct programming language inspired by Python for writing Ethereum smart contracts. Whereas Algorand uses native Python, allowing developers to write and execute smart contracts directly in Python. And we also have TypeScript, which is getting ready for production level applications. The last thing I would also like to say on this point is if your project needs to do 100,000 transactions, let's say whether it's in a month you need to do 100,000 transactions, or a week, or even a day, on Ethereum with the current cost of transaction, which is around $1, it would cost you $100,000. On Algorand, if you were to do the same 100,000 transactions, it would cost $15. So there is quite a difference in costing, making it more affordable for people to practice coding or build a startup, and they don't have to put all of their liquidity into their project with such a huge risk. So it's all about developers, developers, and developers for Algorand. So let's get into the best developer experience for blockchain. So we have AlgoKit, and with AlgoKit tooling, it was launched in March 2023. And since then, AlgoKit 2.0 was released and is now possible for any type of developer to contribute to projects on chain, whether that's the back end with Python or the front end with whatever you are comfortable with, as it's an agnostic framework. With AlgoKit, when you launch it, and you'll see later as well, the template it gives you front end is with React, but you can go in and you can completely use whatever language you want. It takes just 5 minutes to set up your Algorand developer environments from scratch, which I'll also show. As you know, Python is one of the most popular programming languages today, with over 10 million developers worldwide. And Algorand is the only blockchain that allows for native Python programming for blockchain developers. So you don't need to learn a new language. So as we're the only blockchain to support native Python, you may know that Python is actually already used to code machine learning and artificial intelligence, which is really popular. So thanks to now smart contracts. I'll just check the chat there. Okay, it is. Okay, I'll take it a little bit slower. Okay, perfect. So we have a comprehensive developer toolset. AlgoKit changes the game for blockchain developers. So from the command line to the compiler, the top class libraries, easy to call smart contracts with a client generator, instant access to testnet tokens, and a Visual Studio Code Algorand virtual machine debugger. We also have LoRa, LoRa the Explorer. It is basically a blockchain explorer, but for your smart contract transactions or any of the transactions you do, which we will see later on as well. That's a new thing that I'm adding into this workshop. It's very simple. So if I was to quickly go over some of maybe the key parts, the AlgoKit utils, which is what we'll be using. AlgoKit utils elevates your workflow by providing a library of functions that wrap the underlying Algorand SDK. These higher level functions come with sensible defaults and compatibilities for common tasks, making your development process smoother and more efficient. We really want to support you every step of the way, whether it's from these workshops or doing boot camps or hosting regional hackathons. We also have, and I'll put it in the chat in case you want to have a little look before we start doing some live coding in about 10 minutes or so. We also have our AlgoKit landing page. If you click the link in the chat, it will take you there if you're interested to look at it a bit more. We also have our Algo Devs YouTube channel. So if you like watching 15-minute bite videos, or if you like to build a whole NFT marketplace, you can watch a 2-hour video on the Algo Devs channel as well. So I'll also put that in the chat. Cool. So you can build with the AlgoKit tooling, and it literally looks like you're just filling in a form. And whether you want to focus on just the back end or the front end or even both. And when you start to go through more of your journey, we also host like incubators and things like this. But for many of you, this may be your first time even hearing of Algorand. So we'll take it one step at a time. And this workshop is right at the top where you can start and just grow from there. So before we start to go into the live coding, I'd like to share only a few real-world applications. There's many of them, but I'll only show a few building on Algorand, and maybe these ideas will inspire or motivate you to build yours. For those of you who already know GitHub, please feel free to, I've just sent it in the chat, please feel free to go over there and fork to get ready. You don't need to do anything after that. I will showcase, and I've actually created a brand new account so I can take you through each of the steps. So if you're brand new to it, don't worry. Okay, let's see if I can share these here. I've shared my slides in there as well. Somebody was asking. I'll take the questions at the end just so we can keep the presentation going smooth. Okay, perfect. So the first company I'd like to talk to you about is Lofty. They enable fractional home ownership by tokenizing real estate, enabling investors across the United States to build wealth through property value growth and rental income. Some cool stats from them: they have already tokenized 148 properties across 11 US states. The platform has approximately 7,000 monthly active users, and over $2 million in rental income has been generated for users to date. So it's really making it easier to get into real estate investing. And if you're into aviation, TravelX is pretty cool. They're transforming the travel industry with airline inventory tokenization infrastructure. Fancy words. Your airline ticket, basically, they'll take your airline ticket and they'll transform it into an NFT. So it's an NFT ticket, which enables ownership and flexibility. And with this transformed NFT ticket, you can buy and resell on their marketplace, or even send it to your family and friends. So you may be like, why would an airline give up all that control? Well, there's actually many reasons. So if they use TravelX, they can reduce their operational costs for airlines because there's fewer customer service hassles, and there's a possible increase for cash flow as people don't mind buying tickets further in advance if they know the worst case scenario is they can sell it on. So TravelX has already partnered with leading airlines like Flybondi and Viva Aerobus, which is the second largest airline in Mexico, and they're chatting to over 60 more airline carriers. The next one I'd like to talk about is AgroToken. So if you're into the farming side of things, AgroToken connects farmers to financial opportunities by tokenizing their grains, creating digital assets backed by real harvest value. And these guys are based out of South America. So farmers can trade their AgroTokens for essential supplies, leverage them for loans, or access pre-funded credit cards, as they're in partnership with Visa. And AgroToken aims to connect all players in the agricultural value chain, fostering efficiency and financial inclusion for all. The last company I'd like to talk about before we jump into the live coding, which I've sent the GitHub link in, so if some of you want to take a step further and just fork it right now, that's cool. If you're completely new to it, I will showcase all of that. But anyway, Heads Up Pay. they are the first and only interoperable digital payments platform in Afghanistan. So they're transforming the way people send, receive, and manage their money. For example, HazardPay enables users to make airtime top-ups, bill payments, and person-to-person transfers all within a single app. And this eliminates paper-based processes, avoids duplicate payments, and reduces distribution costs for users and organizations. So far, they have processed, and this was back in the end of last year, so I'm sure these numbers have gone up as well. They processed 4.5 million transactions, including 51,000 humanitarian aid, cash transfers, and 1.3 electricity bill payments. Now it will be time to code with Python, but I'm going to explain to you how you can earn your verifiable credential NFT, which is also what you see on the screen there, and some algos. So all you need to do is follow the live coding, and I promise you it's easiest if you just follow along now. So if you haven't got yourself ready, I'll give you a few minutes. It's just much easier instead of doing it all by yourself later. We will be generating accounts, funding them, creating an asset, opting into that asset, and transferring the asset with an atomic swap. I will post a link where we will be entering a code space. All you need is your GitHub account. So if you click onto that GitHub account and wait for further instructions. After that, once we finish the live coding, after the tutorial, you can just push your changes to your forked GitHub repository, create a pull request to the original repo, and inside of this POR, you don't need to include anything, but if you want, you can include what your script achieves if you want to practice learning yourself. And then once I review the code, you will receive a challenge completed tag on your POR, and I will send you a magic link where you can claim your NFT and algos. I will also show at the very end of this presentation, so it's very important to stay for the entire thing, that you'll need to download Pera wallet, which is just a wallet that you can use to interact with the Algorand blockchain. It's all free. Okay, so I think if everyone's ready, we will start with the live coding. I'll take questions at the end as well. So if I share this screen. Okay, so the link where my share screening where my screen is sharing is on GitHub. I've just sent the link onto the chat. I will, if there is a lot of questions, I will take some now before we start, but preferably we'll keep the questions to the very end. Okay, hopefully people are on the code space. So I'm on a totally brand new account. There's nothing on this one, so I'm going to showcase it right here. So if you just have a brand new GitHub account, or if you've never done this type of thing before, that's totally okay. I know some of you probably are advanced devs as well. So let's get started. So if we go and we click fork, very simply, we just click the fork, we click create fork, we give it a few moments so it works. After this, we have created a fork, so an exact replica, but on our own account. And you can see that if you have your username over this side, and we have that there. That's very important. After this part then, what we're going to do is click the green code button, and we're going to go to the code space. So this means you don't need any prior setup. All you need is the GitHub. And we're going to click create code space on main. Now what it's doing is it's just setting up its code space environment, and it will also run at the very beginning. So just let it set itself up, but it will run basically to start AlgoKit as well, because we will be working with a local private Algorand blockchain. I do also have a README, so if you cannot code for whatever reason right now, but you still want to complete the challenge, because I'll give an entire week for you guys to complete this. It's basically just a follow along code, but I do have a README where you can see how to fork a repo and get started on all of that. So now if we see down in our terminal, and hopefully this is on yours as well, it is just setting up the entire local environment for us. You can also click onto your main.py. It is just an empty Python file. And if you're wondering, do you install the pop-up of the Python? You don't have to for this tutorial, but if you wanted to go further and play with AlgoKit after this tutorial, you can then install it just so it works properly. So it can take a few, over here. This is what I was talking about a little earlier. It's just setting up the environment. Perfect, so it's done. It does take a few minutes, so hopefully everyone is following along. After your code space finishes setting up like this, the next thing you do is you just run a quick bash script. And to do this, you just run sh algorand underscore setup.sh. And this will just make sure we have the latest developer tooling that we get to use. It is still currently in beta, which I'll show to you later. But this is the latest dev tooling, so it's pretty cool. We got to play with this. So just run that simple command after you've finished your code space setting up. Should only take a few minutes. And just having a quick look at the chat while that was working. Yes, this whole session will be recorded, so you can watch it back as well. Okay, perfect. And I'll make sure to share the right screens. Perfect. So this is the screen that we're on. All you had to do was wait for your setup to start and then run this sh algorand underscore setup.sh, and then we're ready to start coding. So it's literally only one step, and then you're ready to start coding and interacting with the Algorand blockchain. So hopefully everyone has caught up to this point. There's also a README where it will tell you how to set it up as well if you're a little bit behind, but I'm going to keep going for the sake of the presentation. So now if we're in our main.py, this is a usual Python file. Let's get started straight away. So the first thing we're going to do is we're going to import from the AlgoKit utils library. To do this, we just do from AlgoKit underscore utils.beta, because this is still in beta, Algorand underscore client, import. And so we're going to import a few things, and I'm just going to import it now so it's easier instead of going up and down the screen all the time, so it's easier to follow along for you guys. So we're going to import a few things. The first thing we're going to import is our Algorand client. We're going to import our asset create params, because we will be creating assets, as well as the asset opt in params, our asset transfer params, our pay params, and lastly, or no, we'll keep it to this. This is all we will be importing for now, is the Algorand client, the asset create params, asset opt-in params, and our asset transfer params, and lastly, our pay params. And you'll see how all of these work in a second. Okay, so the next thing we have to do is obviously connect a client to the local net. So to do this, it's quite simple. All we do is we set Algorand is equal to the Algorand client, which we've just imported from the utils library, dot default underscore local underscore net with empty params. And now we're able to have our client connect to the local net. Great. The next thing we want to do is import our dispenser from our KMD. KMD is basically just a key management daemon. It is used a lot in local development because it's very easy to sign transactions very quickly and also to get access to testnet tokens. So to do this, all we need to do is have our dispenser equal to algorand.account.dispenser with open brackets as well. And if we wanted to just have a quick look to see if everything's working okay, let's do a print statement. Dispenser. And to show what the dispenser address is, all we need to do is dispenser.address. Okay, so let's see if this runs the way we expected. And to run this, all you need to do, as per usual with any Python file, is just run python main.py. Perfect. So as you can see, this is going to be our dispenser. So now let's get into the fun stuff. Let's start creating accounts. So if we create or generate creator wallet, how we're going to do this, and we're going to create our first account on Algorand. We're going to do creator, and you can call it whatever you like. We're just going to call it creator, as it will be creating the asset. We're going to do algorand.account.random. And what this does is it just creates a random account. So each time we run the script, it will be a new random account each time. And if we also just run this, you don't have to follow along with the print statements. This is just a showcase. But as we can see, we have our dispenser address and our creator address. If you want to see a little bit more, so if I comment that out, and what I'm going to do is, because you can get a lot of cool information. So we're going to do algorand.account as we're interacting with account, and we're going to get information. Open up our parameters, and we're going to pass through our creator.address. Now, if we run this, we'll be able to see a few more details about this creator address. So as you can see, it is the creator address. Each time you run it, they will work with the way the script runs, even though it's a random account. We have an amount of 0, so we have nothing in our wallet. We have, let's see, we have total assets opted in, nothing as well. And if you can see here, you need a minimum balance, a very minuscule amount, just so the account is active on chain. And that's about 0.1 algo, I believe. So let's do it. Let's do our first transaction by sending a payment. So if I'm just going to comment out these so it doesn't make it messy. So we're going to fund creator address with algo, and this is why we got our dispenser. So let's do it. So we're going to do to send your first transaction, we'll do algorand.send because we're sending information to the network, and .payment. We're going to open up our parameters, and in here, we're going to pass what we imported from above, our pay params. This is just a usual pay transaction, and with pay params, the blockchain can get all of the bits of information it needs. That would be a lot of weird code if we were to do it all from the low-level language. But we're using Python, so we don't need to worry about it. So now if we set the fields inside of this, we have the sender, we also have the receiver, and we have the amount. So who is the sender of this transaction? Well, if we're funding the creator account with the dispenser, the sender is obviously going to be the dispenser.address. Oh, I hope you guys can see my screen okay as well. I will push it up like this. Yeah. If anyone couldn't see it, I hope you. There we go. That should be good. Okay, so we have our receiver then, which will be the creator dot address. And lastly, the amount. So we don't need a huge amount. Let's just do 10 million microalgos, because we work with microalgos when developing. But this is just equal to, and I'll write it in a comment here so it's easy to see, 10 algos. Okay, great. So now if we'll check if this transaction goes through. So I'm just going to print the account again. And if I go into my terminal now, so we should have 10 algos instead of 0 here. So if I run that really quickly, we can see the account now has 10 million microalgos, which is just 10 algos. So it's now active on the chain. You will be able to see it on your local net explorer, which I'll show later. But now let's continue. So we've created an account that works now. So let's create an asset with that account. To do this, we're just doing another transaction. Each time you try to do something with a blockchain, it is always a transaction. So let's call this transaction sent transaction. And we'll have it equal to, and you may start to see a lot of repetitiveness, but algorand.send asset underscore create. Inside of this, we're not going to pass pay params, but we're going to pass the asset create params. Then we have a few fields we have to fill in, just like the above. So we have the sender. The sender is basically the creator of the asset. And so we have the creator address here. And now if you called it something different from above, like, I don't know, account 1, the sender then would be account 1. Next is our total. So how many of these tokens that we're going to create do we want to? So let's just do 100. You can also set the asset name if you wanted. So let's call it Web3 pack. We're going to create the Web3 pack token. And we're also going to do the unit name. So we'll just say Web3 pack. And yeah, we can also, if we really wanted to, but I'm just going to keep it simple for now. But if we really wanted to, we could set the manager address, and that basically means with the asset, you can be able to do some more stuff and manage it. We could also set the clawback address, which if it's set to, you can set it to true or false. And if you set it to false while you mint, that means it will never be on. But a clawback is basically when, if you have the clawback address, you can claw back tokens from other accounts of that token. And a freeze, which is used, which can also be turned off and on, but it's very important for regulatory purposes, that if something was going wrong, or say a hack or some malicious intent was happening, if you have a freeze on, you can then freeze the entire asset. So that means that asset cannot be moved anywhere. But we'll keep it simple for now. But feel free if you want to check out all of the code. I will send this code on afterwards as well. Next, after we create the asset, we need to take the asset ID, because that's how we can send the asset. We need to know what asset we're sending. So to do this, we're going to extract the confirmation and index of the asset. So to do this, let's set our asset underscore ID is equal to the transaction above that we just created. So it's equal to the transaction above. And inside of the transaction above, we're going to take the confirmation and the index. Asset index. Perfect. So if we wanted to, I will quickly print that out because that is kind of important. If we wanted to print the asset ID, all we need to do then is just print it out just like this. So let me make sure. Yeah, okay, cool. So what we should have then, once I run this code, and I'm going to clear this because it's a bit messy now, but we should see a 4-digit asset ID. So let's run and see. Everything's going good. It's always good to check your code. Perfect. So we have created a Web3 pack with the asset ID of 1003. Now, please remember, if we run this again, it would create a new asset ID because each time we run the script, it's run a whole new time. Okay, so now we have an asset. We created an account. Let's create another account so we can transfer this asset. So, I mean, very simply, we could literally just go up and we could take the top one. We can paste it and we can call it receiver underscore account. And there we go. That's how you create another random account on Algorand. And then we also need to fund it because if the wallet has nothing inside of it, it is not activated, it cannot do anything. So let's fund it so it can do some fun stuff on the blockchain as well. So if we take that transaction that we did earlier, we paste it down here. The only thing we need to change as the dispenser we're still grabbing tokens from, we just need to change it to our receiver account. And that's why I did the underscore account, because didn't want to confuse it with the receiver field. Nice. So we can then print this information out. And this is just to show. And I'll take the asset ID comment off. Let's have a look at our receiver account address. Great. So we can see we have our receiver account and it has the minimum, it has a good balance required, has 10 algos. So now the next part, we need to send from the creator to our receiver the asset token. So if we create that transaction right now, we're going to call it asset transfer. And we have that equal to algorand.send, as per usual, asset transfer. We open up the parameters, and what we pass through is our asset transfer params, which we imported from the above at the beginning of this live code. Inside of these parameters, we need to fill out a few fields, like the sender. And the sender of the asset transfer, well, who has all of these Web3 pack tokens? The creator address. So the sender is our creator.address. Don't forget the commas as well. If you're having any issues, just remember the commas. Then our receiver is equal to receiver account.address. The next part is very important. Well, if we're transferring an asset, we need to know what asset we're transferring. So that's why we extracted the asset ID. So we set the asset ID field to, and if you remember, we simply extracted it into the variable of asset underscore ID. So let's do that. Okay, cool. Now we just need to declare how much of the amount we want to send. So if we have the amount equal to, well, we created 100 of these tokens, so let's just send, we'll just do 10. Okay, cool. So now if I was to run this, and I love doing this, but let's see if it works. It wouldn't be a live coding tutorial if I didn't deliberately showcase an error for learning purpose. So as we can see, we received an error by trying to transfer from the creator to the receiver address the asset. So it says receiver error must opt in. And if you remember from the very beginning, we also imported an opt-in feature. So this is an anti-spam feature that is ingrained on Algorand. So when you send an asset, the user would have to opt in. But we also have a cool update coming that's called an asset inbox, where if I was to send you an asset that you didn't opt into, you can still get it, but you can have the choice. You have the choice whether you want to keep it or you don't want to keep it at all. So let's fix this error. So what we need to do is we need to opt in. And so what I'm going to showcase during this as well is the atomic transfer, which in the presentation, if you remember, is the layer 1 feature of Algorand. If you were to do this on Ethereum, you would have to do a lot of work and a lot of effort. And I'm going to show you how to do an atomic transfer where we'll opt in, we'll have the receiver pay for Web3 pack tokens, and we'll have the creator address send the tokens after the payment. So let's do it. So I'm going to create a new transaction group. So we're going to create this transaction group, and we're going to call it group transaction is equal to Algorand.new underscore group. Quite simple. And now let's start to do all of those transactions that we were going to do before. Now, so the first one is we need to opt in. So to do this, we're going to add a transaction to our group transaction. So we do group underscore tx dot add underscore asset underscore opt underscore in. We'll open up our parameters and pass in, as per usual, our asset opt-in params. Then we'll open up these parameters, and it's very simple to do an opt-in. Basically, what you need to do is in the sender field, you need the account that is wanting to opt in, and in this case is our receiver account, as it's not opted in at the moment. And then all you need to do is declare the asset ID. So asset ID is equal to asset ID. And this is how you opt in. But now that's only one transaction. We want a group of transactions to showcase how powerful atomic transfers. So now let's do the payment transaction. And we've already done one above. So let's take a payment transaction from above. And if we paste this down here, now the sender is not the dispenser. The sender will be the receiver account, as we're going to pay for some Web3 pack tokens. So the receiver of the payment should be the creator address. And we're not going to send 10 algos. We will send 1 algo. So we just need to take away a 0. And that is equal to 1 algo. Fantastic. Also, you may see we did copy and paste the payment transaction, but we need to add it into the group transaction as well. So to do this, we just do group underscore tx dot, and instead of actually doing the Algorand dot send, all we need to do is group underscore tx dot add underscore payment. Great. And now lastly, what we need to do is the asset transfer params. And as you already know, we did do this above to showcase the opt-in error. So there's no point writing it all again. If you just copy it, delete it from above, of course, or else the error will happen again. But if we paste it down here and just add it into the group transaction, so let's do that. Group underscore transaction is dot add underscore asset transfer. A lot of decimals. Okay, cool. And so in this, we've already set out that we're going to send 10 of these Web3 pack tokens. We're paying for it, and the opt-in happens. So now what we need to do is basically execute the transaction group. And to do this, all we need to do is have our group underscore transaction dot execute with open parameters. Great. So now we obviously need to check does all of this work. So let's have a look at our prints. What I'm going to do is I'm just going to take some from the above. So if I take this one, The rest are commented out. Okay, great, because there's a lot happening. So we'll print off that, but what we'll also do is, because if we keep printing it off in that way, we'll see a lot of things. And so let's break it down. And this is also quite handy to know how to look inside of getting different points of information. So if we do the receiver account asset balance, then we just have the Algorand dot account dot get underscore information receiver account dot address. Outside of this, we open up and we look at the assets, index 0, and we want to know the amount. Great. And then if we also wanted to see the same thing for the creator address, we can. Creator asset account asset balance, get information underscore creator dot address. Perfect. So let's run this and have a look at what happens. Okay, cool. So, well, we can see obviously this is the receiver address, I believe. So we can see here, there's one algo that did go and it went to the payment of the creator address. And we can see that it is opted in, so the atomic worked. And as you know, if you run an atomic transfer, either all of the transactions succeed or none of them do. So we can see our receiver account asset balance has 10 because it was sent 10 by the creator account, which minted 100, but now has 90. Now, I would also like to show you something very cool, because obviously it might be a bit hard to see all these different types of transactions. You can follow along with this part too, but you don't have to. I'm just going to show you. I'm going to make my ports of my AlgoD public, as well as my KMD and my indexer. And now what I'm going to run is AlgoKit Explore. And this will take us to LoRa, the Explorer, where we can have a look at all of these different types of transactions. So if I run that, we'll get a pop-up, and you just open that, and I'll share the screen. And then inside of here, we can see we've been doing a lot of transactions because we kept running the code over and over again. But if we can see from around here, we have a lot of one transactions where there's just one transaction happening where we're just like sending a payment. But here we can also see we have 3 transactions, which includes the asset opt-in, the payment, and the asset transfer, which is pretty cool. And so if you wanted to also explore that and look at all the things that are happening, for example, if we click on here, this is the opt-in. An opt-in is basically when you send your own account 0 of the asset you want to opt into. We can also have a look at the asset transfer. We can see that 10 Web3 pack tokens transferred from one account to another. We can also click on our asset, and we can see the asset ID was 1011. The name is Web3 pack, and etc. So it's pretty cool, pretty interactive. Great. So that is the live coding section. So if you have been following along, I'm going to show you something which will make it a lot easier. You may already know already, but if you forked it in your own repo and you followed along, all you need to do now is go to your source control. You could write finished challenge, anything, and you press commit. Then after you commit the code, you just sync the changes, and then it will be added to your own repo. And then you can simply, if I go back over here to the file outside of the code space, if I was to refresh, we can see if we enter inside of here, all of the code we've just done. So this makes it easier then. Once you finish that, you can go back to the main, one of the main forks, and to pull a request, what you can do then is go to Pera, create a new pull request, and you just compare what you've just done to the main one here, and it's very simple. But now I know it is getting late, but I still have a little bit more I want to share with you all. But that is the live coding. So just to reiterate, to earn your verifiable credential NFT, which is really cool, it's a proper proof of a certificate, as well as you can add it to your LinkedIn profile. But what you need to do is, with that session we've just done, you need to submit the code so you can push the changes to your forked repo, and then create a pull request to the original repo. Then after code review, you'll receive a challenge completed tag on your pull request and a magic link to claim your NFT and algos. And you'll claim it with Pera wallet. But I'll showcase some of that at the end as well. But you have 1 week to complete it. I might be nicer, I might give it more time as well, but I'll give it a good few days. So 3 or 4 days before I look at the pull request and give the magic link. So take your time. Okay, great. So if I was to continue then, I would just like to show you, and I'll put this in the chat as well, the installation AlgoKit process. So the AlgoKit link is in the chat. Please feel free to pin it for later, but watch the presentation for now. So this is from installing to deploying a smart contract with Python using AlgoKit in 2 minutes. So I was using a Mac, but we also have processes for Windows, for Linux, for whatever OS system you want to run on. But basically what I'm doing is I'm following the instructions. I download Homebrew, starting completely fresh. I make sure it's on the right path, and I run brew help to get started. I'm going to put this into full screen so you can see it better. Once you run brew help, if it comes back, you know it's worked. Next, you would need to install Docker. So we use Codespace, which run our local blockchain. But if you want to get even Codespace for a certain time, you will use up enough space and you won't be able to continue on. And every month they delete your code spaces anyway. So to save your cool projects, it's better to take it to local. So once you install Docker and you install AlgoKit, all you need to do is open up Docker, but you don't need to do anything after that. All you need to do is just open it, and you see there's no containers. After that, we're going to initialize our first AlgoKit project. This one is just a smart contract. And as I mentioned earlier, you might have remembered, I said it's just like filling out a form. After it installs all of its dependencies, you can choose if you want a Git repo as well. But you open up your project file, you enter inside of the workspace, and as you can see, we have our smart contract template given to us right there. It's just a hello world to get started. Then if you go and you build and deploy, so you can build it first or deploy it after, but if you're running it for the first time, which this video does, we've just installed AlgoKit, we just got all of our dependencies, like all of our prerequisites like Docker. So now we can see on the screen, it built and it deployed. We received hello world, and we also deployed the app successfully. Before we did that, and we seen our Docker, we had no containers, but from running AlgoKit and just building and deploying, it will automatically set up all of these containers for you. And this is just like a private mini Algorand blockchain, which is pretty cool. And so the link that I sent in the chat takes you to the landing page, and then you can go and see how to install it. But let's continue. So I really quickly want to show you that, we've talked a lot about real world assets. But I want to show you the entire ecosystem. If we were to just quickly skim over real-world assets, we went through some of these before, but we have others where it's to do with music, or it's to do with carbon credit tokenization, or not supply chain, but agricultural commodity tokenization. It's pretty cool. From all across the world. You can also use blockchain for data traceability and tracking for many reasons, for having more authenticity, or ensuring the work that is happening is not from child labor, or you know exactly where your food is coming from, and etc. So LabTrace is really cool. It allows data authentication solution for clinical trials. So that basically means that you won't be able to manipulate clinical trial results, which is very important. We can also see Whole Chain and Lavazza Coffee. They use supply chain traceability. If we were to look at DeFi protocols as well, we have DeFi protocols like Folks Finance that allow lending, borrowing, and trading markets, Tinyman, which is a decentralized exchange, Vestige for order routing and DeFi tooling, and many more. On the stablecoins, digital money, and payment side of things, we of course have USDC, a fully reserved US dollar-backed stablecoin. There's also cool ideas like X-backed XUSD, and that's a decentralized stablecoin backed by various digital assets, such as Bitcoin, gold, silver, GoETH, and Algo. And there's also like Daffy for point-of-sale solutions. Many different ideas. On the NFT sides, the non-fungible tokens and the gaming, we can see we have Exa, Algo X NFT, Dartroom, Rand, Shuffle, all NFT marketplaces. And we also have Gunny and Fractal Monsters, which are games. And we can also see NFTs can be used as insurance policies with day by day. And there's probably even more in the ecosystem. Across our ecosystem tools and infrastructure, Pera Wallet is a great entry to begin your journey with Algorand. It also includes an Explorer, and you can download it on your phone through any of the app stores. Gore is a cool one as well if any developers want to extract real-life data onto blockchain. Gora is an Oracle network. We also have NFT, which is a naming service. So for example, you have a bunch of letters for your wallet address. With NFT, you can buy, let's say, web3pack.algo, and that can also be used to send assets to a wallet. But we have a lot of ecosystem tools and infrastructure. With accelerating adoption, we want to show and also show how we can support you if you want to begin building on Algorand. So with the developer tooling, as you can see, we're working really hard to get the developer tooling to the devs. Instead of creating all these new languages where people have to learn completely new languages, which is just takes a lot of time. So that's why we brought native Python. We're the only blockchain to have native Python. We also want to support developers with resources, docs, and one-to-one real-time support. We have a Discord as well. I'll send that link in a bit. From the ecosystem success, supporting builders and startups in the ecosystems with programs, initiatives, and mentorships, building crucial platform and infrastructure tools to support application development, launching critical exchange partnerships to expand access to the Algorand ecosystem. Then with the Algorand Ventures, where they make direct investments in Algorand-based companies, from business development and partnerships to tokenomics and governance and marketing, promoting Algorand technology and its ecosystem of applications via media, content, community channels, events, and more, all with the goal of driving broad awareness and increased adoption. The next thing I'd like to show you, this is really cool, and I think that you guys as developers would really appreciate this as well. So I showed you how to install AlgoKit, and you can run a smart contract template, and it will set up everything for you quite easily. I also want to show you that with AlgoKit, you can get a full stack template as well, where it builds out your... I'll play it and I'll explain while it's running as well, actually. That's probably the best idea. So you do AlgoKit and initialize your project. You choose smart contracts and dApp front end, the language you'd like to do it in, which of course is Python. Next, you open up that project and enter the workspace. Inside of this, you notice we have a dApp contracts and dApp front end. So if we click inside of it, we can see the contract. It's the same template contract again. Now what you need to do each time you have a new project is either do AlgoKit localnet start or AlgoKit localnet reset. You got to make sure your private blockchain is working if you want to execute interactions on that network. After this, what you would normally do is build out your contracts first, because if you don't build them out, the front end won't be able to work with them. Then when you run the front end, which all of this is giving to you, we open up our localhost. We can see we have a connect wallet function already, where it connects your localnet wallet. You can click on that, and this is an older video, but what it will do now is redirect you to LoRa, which we've already used in today's session. I just created a wallet to showcase some of the functionalities that are already given to you, like a transaction demo, where we've already essentially done this ourselves today. We've sent a payment transaction. This is just with a front end on it. You sign the transaction, we refresh, and you can see that one algo went through. Next, with this template, it also makes sure that your front end and back end smart contracts, your front end and your smart contracts back end communicate together. So we're just going to send a simple hello world, but we're filling in, say hello to your Algorand smart contract. Once we send the application call, we sign the transactions. We can see on the bottom left, hello AlgoFam. This is all given to you after you download AlgoKit. So if you think you're interested in diving more into AlgoKit and beginning your algo dev journey, please feel free to take a picture of this QR code or scan it right now. I have sent the link in a few times as well into the chat, but I'll send it in one more time because it won't hurt. Nice. And now I do want to show you, because some of you may be wondering, after you complete the challenge and you do the Pera request after you fork the repo, how can I claim, or how do I set up Pera wallet? So let's do that next. So, and I'll send this in the chat as well. You can download it on Android or iPhone very easily. I just sent the links in there for Pera. But if we open this up, I'm going to put it on big screen so you can see it clearer. So we're going to create a new Algorand account with a 0 balance. All you need to do, once you download Pera, you'll be taken to this page. You'll click create new account. It will say create a passphrase backup for your account, because it's very important. You should write this down on paper, but if you don't have time and you're in a rush, what you can do is skip for now. After that, you can just give it a name, and then you've created an Algorand account on Pera. After this, what I'll do is I'll send you a magic link or a QR code that you'll scan or click the magic link, and this will be how to claim your NFT and your algo's reward for doing this workshop. This is just a tester one, but I'll only send you that if you do the pull request correctly. After this, you'll proceed to claim. You'll be redirected to Pera to pick the Algorand account you want to connect to. Once you go back to Go Pausable, it will be like, do you want to claim with that address you chose? You say yes. You'll be taken back. You sign the transactions, and then you will receive your algo and your NFT. And you don't need to worry about having no balance in your algo wallet, because Go Pausable covers that for you within the minting process. So all you need to do is finish the workshop challenge by just doing the live code we did today, make a PR request. In a few days, I'll check it, and if it looks good, I'll put the challenge completed. You'll be sent a magic link or a QR code, which you'll scan or click. You'll do the claim process after you set up your Pera wallet account, which may have 0 algos in it, or if you went to some of my other workshops, it may have some algos in it as well. But a very simple process that is quite seamless. So if you would like to scan the Pera QR code there as well, but I really want to say thank you so much for your precious time and coming to the Intro to Blockchain and Developer workshop. I hope it was meaningful and you were able to take away something worthwhile. If I didn't think it was worthwhile, I really wouldn't be doing this. So please do not hesitate to reach out to me. You can connect with me on LinkedIn, Sarah Jane Kenny. And once again, feel free to connect across any social media. So yeah, make sure you download the Pera wallet, finish up that challenge. And now is the time for questions if we have any. Okay, so I hope you guys really enjoyed it. Any questions? If you have a question, I think you can just unmute and ask. Oh, here's a question in the chat.
Hey, Sarah.
Hey, how's it going?
My question is regarding the security of the smart contract. Whenever we are in the Solidity, so we have many security uh, efficiencies. But in terms of Python, how we can make our smart contract really secure?
Okay, your voice is a bit muffled. I'm afraid I can't hear the question. Could you write it in the chat if that's okay, Ahmad?
Yeah, sure.
Ma'am, I have a question.
Okay, Newman, yes, please.
Today I deployed my smart contract on Cephala testnet, but it detect my real ETH. It detect my real ETH. Can I deploy on Algo if I try to for a testnet?
Yes, so if you wanted to use testnet on Algorand, of course, when you deploy smart contracts on testnet, it's all free anyway. You can take the testnet tokens. Maybe we'll do a more advanced workshop in a month's time with Web3 Pack where we go deeper into the smart contract side on Algorand. But yes, on testnet, yeah.
Whenever I try to do in a different blockchain, it always demand some amount of Algo or ETH or Cephala testnet. But how can I get these small amount of testnet to be just like to get the funded account?
Yeah, okay. So on Algorand, let me send it in the chat. We have an Algorand dispenser. So like you've seen today, locally, we had a KMD one. But when you're doing testnet, we use the
but
Algorand
it detect
testnet.
my real ETH today.
No.
I lost my $15 roundabout.
I'm sorry to hear that. I've sent the testnet for if you're deploying on Algorand on testnet, so you can just dispense from there and it'll be all free. Also, the transactions cost from Ethereum and Algorand is quite a big difference. So each transaction only costs a fraction of a US penny. But you don't need to worry about those fees when you're working on testnet or local.
Okay, I have to change my local host to Algorand or just Cephala.
Well, to get started with Algorand development, I really would recommend you go to, let me get the link. You just go to here and get started, read the documents on AlgoKit. Now, if I'm just going to have a little look at the questions in the chat as well, just to be mindful. I know it's getting late for everyone there.
Okay,
so there was a question. Thank you, Newman. There was a question in the chat from Zane a while ago saying, how can we ensure that Python code used in Algorand smart contracts is optimized for gas efficiency? Are there specific patterns or practices you recommend to minimize resource usages? So a big point in that straight away is Algorand doesn't use gas. We have a set transaction fee each time, which is a fraction of a penny. And just to go a little bit more on that, to optimize Python code in Algorand smart contracts, you can minimize operations, so you could reduce the number of logic operations you choose to build with. It kind of all really depends on how complex the smart contract you're building is. Now, if I was to look at some more questions in the chat as well. So Ahmad said how the Python smart contract security standards are managed. Is there specific contract auditation required for that? Okay, interesting question. So obviously when you build a smart contract, once you deploy it, it is on chain. So you have to be very mindful of that, which I know many of you already know that. So when you're building a smart contract, you would do it from localnet, then test on testnet, and you can choose to get it audited from third party, or you can choose to have a bug bounty on it and really test the strength of your smart contract. But I guess the security standards, there's none officially that I can think of. But of course, nobody's going to trust your product if you're not going to get it audited at all. So I guess that's a personal smart contract preference of how much you want to get it tested. There's a question from Mohammed. Does Algo only use Python? Can't we use JavaScript? And you can use Python for smart contracts or TypeScript for smart contracts, but we also have four SDKs: Python, JavaScript SDK, Golang, and Java. I'm going to get you guys actually the Discord, and I really invite you to join our Discord as well. So if you have more really cool questions, please put them in there. Let's have a look. Another question: are there enough resources of Algorand just like Ethereum? So to that question, I think this is possibly talking about Algorand's token called Algo. There's 10 billion of them. It's a set cap at the moment, and it's enough resources currently anyway. I hope I answered that question correctly and I didn't misinterpret it. Okay, if there is any more questions, what is an NFT? Well, it really depends how deep you'd like to get into it. But an NFT could be, it stands for a non-fungible token, but they're just pieces of asset on the blockchain, and it could be like a piece of art or digital content. It could even be a video or music, but you can use it in different ways. And as we've also seen in some of our ecosystem, you can use it as like insurance policies or maybe as like legal documents. There's some cool ideas that you can do with NFTs. Okay, so to explain the other question, should I be charged from Solidity to Pi for smart contracts? So if you're working on testnet on Algorand, you won't get charged for anything as it's testnet tokens. They're not real value. For smart contracts, comparing to Ethereum, which I did a thread on before as well, there is a stark difference, so a big difference of the cost. If I can find that really quickly, I think it will be helpful for you, Noman. So if I can just try to find that really quickly for you. Okay, here it is. So I'm going to send this in the chat. This is a thread basically explaining, and I'll say it here as well. So on Ethereum, if you were to deploy a token, that can cost anywhere from $500 to $1,000. And every transaction, like transferring tokens, can cost from 50 pennies to $5. And obviously when you're say doing a simple task like deploying a token like we did today on local, but if you were to do it on mainnet, you could do it in a fraction of a penny on Algorand. On Ethereum, you would need to build a smart contract and with smart contracts comes possible bugs, which could cause exploits. So let me send this into the chat. Here you go, Newman. Another question: what is the vision of Algorand about cross-chain? Does Algorand support cross-chain or not? We support cross-chain. We think cross-chain is the future. It's all about making the best user experience for people, whether or not they know they're going to use a blockchain or if it's in the backend, because not everybody needs to know about blockchain. But is it a great piece of technology that the world can benefit from? I believe so. But the vision, yes, we're very happy for cross-chaining. For example, actually, our CTO, John Woods, he has worked across Ethereum and Cardano. So he also has a lot of network around the space, and many people inside of the Algorand Foundation too, and we're very happy for cross-chain. So yes, it's better if we all work together. Is there any more questions? Please feel free. I really appreciate all of your time as well. And if you have any trouble with the challenge, please feel free to DM me on LinkedIn, Sarah Jane Kenny. I'll actually just get you my LinkedIn now. And I will try to help you as best as I can. We have another question. Hey, Sarah, is this the only code challenge presented online that we have to submit? And are there any other challenges we can practice? Thanks. I love that question. That is my favorite question of the day. So this one, for this workshop, all you have to do is what I showed in the live coding to earn your really cool NFT and some algos. But we did actually have a series where we did algo coding challenges where you debug smart contracts and everything. I think that's currently not live, but you can still look through all of the code. So let me get that for you as well, because it's actually really cool. And you can still do the challenges. You just won't, the NFT, there was just an NFT on offer for it. But let me see if I can try to find it. And you can do it with Python challenges too, so it's really cool. Okay, here it is. So please check out this repo where you can look at all of the other coding challenges. And also to that question, is there any geographical restriction to claim the certificate? No, I do not believe so, and I'll make sure I double check as well, but it should be all good. You'll receive the magic link after you do the PR requests. I'll look at them in a few days to give people time, so not just taking each one as it comes. It'll be nice to get it all done in bulk, but I'll give 1 week. If I do see there's more people giving it a go, I might extend it as well. That'll be nice. Another question. So can you explain again the challenge for the reward? Yes, I can. That's no problem. So let me just get it on the presentation again. Okay, so the challenge is basically you create an Algorand account, you fund that account, you create the asset, then you create another account, you fund that one because it needs to be funded to be active, you opt into the asset, and then you transfer the asset from the account that made it to the receiver account. Now, for those of you who have came late and maybe missed the live coding, you don't have to use the atomic swap, but I do encourage you to try and use the atomic swap. It's very easy to create a group transaction, and I'm sure this recording will be out soon as well. But I also will, if you look through the GitHub, you'll be able to find hints as well on how to do it all. But it's basically what we just did in the whole live coding. Make sure you fork the repo before you do it as well, because then you can easily add it back into the session. Another question, is Algorand good for transaction transparency compared with Algorand? So I'm pretty sure Ethereum is a very public blockchain as well, so everything can be seen. But yes, Algorand is really good for transparency, and the really cool thing is every 12 minutes, that history of the transactions are all quantum secure as well, thanks to state proofs. If you want to have a look at the mainnet of Algorand, you can use the Allo Explorer, which I sent into the chat. And inside there, you can have a look at, there's some cool stats. Actually, maybe I'll share it. So if you can see my screen, this is inside Allo Explorer. You can see the block time, it's under 3 seconds. You can see the transactions per second happening at the moment, the circulating supply, and you can also learn a little bit about blockchains. But inside there, you can have a look at different types of transactions you want to look at, accounts you want to look at, and more information there. Okay, let's have a look at the questions. When is the AlgoKit 3.0 coming out? Any idea? I am not sure. It's not the main thing on my mind, but I'm sure it will come out very soon. But it's more important, and maybe not when, but what will be coming out with it. So with AlgoKit 3.0, it's basically the way AlgoKit works is you have your high-level language, and then you have all the different steps to have it compile into Teal, which is a transaction execution approval language, which is the native language of Algorand. Now it's Python, thankfully, but the low assembly language Teal can speak to the AVM, the Algorand virtual machine. And so with AlgoKit, what they've basically done is they've condensed this experience for compiling thanks to the Puya compiler. And on top, we have our high-level languages like Python and TypeScript. And so with AlgoKit 3.0, they're going to add another common language that you learn in high school or in college. So it's pretty cool. Though I'm not sure if I'm allowed to say which one exactly. There's another question. How does Algorand's pure proof of stake consensus mechanism handle high network travel? And are there any observed inefficiencies or bottlenecks during peak times? This is a great question. So pure proof of stake, the consensus mechanism, allowed for a numerous of benefits from what is known as the trilemma for security, scalability, and decentralization. It was sort of solved it. But the pure proof of stake, or PPOS, handles high network traffic by, as I mentioned before, how the consensus works, but it's selecting a small group of validators for each block, ensuring quick consensus under heavy loads. When there are peak times, so for example, I think there was a community developer who was able to get like 9,000 or 9,500 transactions inside of one block, and the network itself was perfectly fine. There was no slower block times or anything. It handled it perfectly. But what we did get to see is that a lot of the front ends, the applications built on the blockchain, they had a little stall. And so, but what's the benefit of that is basically after that, they fixed what they needed to fix, like to be able to handle these heavy loads. And now they're able to handle that. So we're much more ready for really bringing on the adoption. So it's good stuff when stress tests happen. But no, the network didn't have any trouble at that moment. But of course, we're very lucky we've had zero downtime, and hopefully it continues that way. But with each blockchain, everything's happening live. We don't know what will happen. So tell me about Algorand smart contract auditing. Is there any specific tool? So I'm not an expert in smart contract auditing, actually, but if you join the Discord, which I'll put in the chat, and if you ask this question, all the senior devs would love to answer. But basically, with smart contract auditing, what I know is that you can just outsource it from a third party and get your smart contracts audited, which is quite a usual way to go about it. We are making UTXO in task, right? I'm misinterpreting what UTXO is. If you could let me know what that is, I'll be able to answer your question better. If it's a transaction, yes, there will be quite a few transactions inside of the task. Another question, Pera wallet, why not other crypto coin?
बोल के दस
Oh, sorry, I thought you had a question. Did you have a question? Please feel free to unmute and ask a question. That's no problem at all. Okay, so just quickly back to that, is Pera wallet is a wallet, and it's like basically really easy UI. It has a great explorer. It's just a great gateway into Algorand. We obviously have other wallets like DeFi and stuff like this, where if you're into swapping tokens, it does it in a very good way, where it can get you the cheapest prices. Where can I learn about blockchain in detail? Well, you are starting off in the right place. Go to workshops like this, go to in-person ones. Web3 Pack are great at facilitating workshops, so definitely stick with them as well. You can use, for example, you can, with allo.info, they have a section where they talk all about blockchain, which I'll send in here too. So there's a lot of articles online as well, but it's always best to take resources from different parts and put it together. So let me have a look at some other. What is the advantage of this one blockchain? So there's many different advantages. If I was to just pick some off, obviously, as I'm into cryptography, we're leading in post-quantum security. We are also have that you can use Python, the only blockchain to allow Python coding for smart contracts and etc. We also have very fast transaction times, under 3 seconds, with instant finality. So it doesn't give an opportunity for the waiting time, which many other blockchains have, for a rollback or for something to happen, like a malicious attack. And you also need instant finality for payments to really happen across the world. So that's just a few. It's also very cheap for transactions. If you have questions, please feel free to unmute. I'm just reading some during the chat as well. And just a quick one down there. Well, there's quite a lot of message in the chat, which I'm just catching up on. But can we get this video recording session? Yes, you will definitely get it. Web3 Pack will share it with all of you guys. Yes, you'll definitely get the recording. Don't worry. Maybe it'll be uploaded to a Google Drive first, so people can look back on the live coding before it gets made extra pretty by production and put onto YouTube. Okay, let me read this. So UTXO, unspent transaction output, is a fundamental concept in blockchain, particularly in Bitcoin, representing the amount of cryptocurrency that remains after a transaction. Each UTXO is a discrete chunk of currency that can be spent in future transactions. Transactions consume UTXOs as inputs and generates new as outputs. Okay, I would have to personally research more into the UTXO model that Bitcoin uses. But please feel free to, maybe there might be some more Bitcoin experts in the Algorand Discord. Okay, perfect. Is there any more questions? I know it's getting late for all of you. I don't want to keep you up too long. I really do appreciate you coming to this session, and hopefully we can do some more together. And I look forward to seeing you guys build on Algorand. Come join our incubators as well. We currently are hosting one at the moment. And we also will have regional hackathons and global hackathons as well. So there's lots of developing to be doing and etc. Okay, perfect. Well, I think if everyone's happy, please feel free to leave the workshop. Thank you so much again. I really do appreciate it. Let's connect on LinkedIn. And Kanza has sent through the workshop slides, the AlgoKit documentation, also the repo that you need to fork and then do the live coding that we just did, and also download Pera so you can make sure you can complete the challenge and earn your rewards. Okay, perfect. Thank you, everyone. Really appreciate it. Have a great day or a great night. See you next time. Thank you.